Let's determine the molecular geometry for XeO3. This is xenon trioxide. So when we do molecular geometry, we need to start with a valid Lewis structure. So this is the Lewis structure for XeO3. So if we look at this table, we have steric number. That's the number of things bonded to the central atom, the xenon. We have 1, 2, 3, 4 things. So we have a steric number of 4. And one of those things is a lone pair of electrons. So we have one lone pair. So we come over here and we see that we have a trigonal pyramidal molecular geometry for XeO3. Bond angle should be about 109.5 degrees. Let's look at this in 3 dimensions. So the purple, that'll be our xenon atom, the central xenon. Let's add those 3 oxygen atoms, and they're all double bonded like this. Right now we have this planar, this trigonal planar molecular geometry. But don't forget that lone pair. It occupies space, and when we add the lone pair, it forces those oxygen atoms down. That gives us that trigonal pyramidal molecular geometry. And again, the bond angle should be about 109.5 degrees. It turns out it's actually around 103 because this lone pair is pushing these down more than another atom would. Let's go back to our Lewis structure. We could also use the AXE notation to figure out the molecular geometry for XeO3. A, that's the central atom, that's the xenon. X, that's the number of atoms bonded, 1, 2, 3 oxygens. And then E, that's the number of lone pairs. We have one lone pair. AX3E, if you look at that, trigonal pyramidal, just like we found before. This is Dr. B with the molecular geometry for XeO3, xenon trioxide. Thanks for watching.